Good morning, students. Continuation of the previous class. The system of particles in rotational motion, that circular motion only we are still discussing. That centripetal acceleration already we have discussed. Derivation done in the previous class in the vectors topic. Centripetal acceleration is v square by r or omega square r v omega r. It is independent of the mass. But whenever what is the direction of centripetal acceleration? Centripetal means towards center. Centripetal means towards center. So centripetal acceleration is acting towards center. Whenever the acceleration is there, the particle is having some mass, then mass into acceleration itself is a force, and we call it as a centripetal force. Centripetal force is equal to mass into centripetal acceleration, m into AC. Just multiply the centripetal acceleration with the mass, you will get a centripetal force. Centripetal force is also acting towards the center of the circle as the object is moving in a circular path. Omega, v omega already we have taken. Omega is perpendicular to the plane of the rotation. So if you get the relation, if you know v and r, we can find out in terms of omega and r. The relation we have to use is v equal to omega r. If you take the uniform circular motion, UCM. In the case of uniform circular motion, v omega are constant in magnitude. Therefore, angular acceleration alpha is 0 and the tangential acceleration is also 0. At velocity and acceleration, what we are considering is at the given instant only. Centripetal acceleration is acting towards the center of the circle. Centripetal force is acting towards the center of the circle. But whenever there is a force, object should move in the direction of the force. Why the object is not moving towards the center of the circle? If the force is there, it should move. And why the centripetal acceleration is produced? That is because of the change in direction of the velocity. From point to point, velocity direction changes. Due to change in direction of velocity, the acceleration produced is called as a centripetal acceleration. But due to change in magnitude of the velocity, what you get, the whatever acceleration produced is called as a tangential acceleration. Here in this case, the object is not moving towards center of the circle, means that force, which is a centripetal force, is balanced by opposite force, that is called as a reaction force. Action is a centripetal force, means reaction force is opposite that, called as a centrifugal reaction. In this case, centripetal means towards center and centrifugal means away from the center. Centripetal means towards center of circle, and centrifugal means away from center of circle. Centripetal force is towards center of circle. Centrifugal force, we are not using the term, be careful with the word. It is not centrifugal force, it is a centrifugal reaction. Action is towards the center of the circle, centrifugal reaction is away from the center of the circle. So these two forces are equal and opposite, and hence they cancel. For the object moving in a circular path, centripetal force is compulsory required. Without centripetal force, object will not complete the circular motion. And it is not, the object is not moving towards center, it is always trying to go along a tangent only. But the centripetal force is trying to pull it towards center, but balanced by centrifugal reaction. The result is that the object moves in a circular path, and always the velocity is along the tangent of the circular path. So centripetal force is numerically equal to centrifugal reaction magnitudes in magnitude, but opposite in directions. So centripetal force is equal to centrifugal reaction. You should not use the word centrifugal force. Centrifugal force, what is that, we discuss later. So these two are equal and opposite, but you will not be asked the expressions or problems for the centrifugal reaction. Just have an idea that why the object is not moving to center means that is centripetal force is balanced by centrifugal reaction. But where do you notice the centrifugal reaction? If the object is moving in a circular path, take an object, tie to the string and rotate it. What is required for this object to move in circular path is tension in the string. If the string is not tight, the tension is nothing but the force inside the materials. String is tight means tension is there. Loose means tension is not there. If it is tight means there is a possibility, we have the centripetal force for this string. If the string breaks, there is no centripetal force, the object cannot move in a circular path. If the string breaks, the object will fly along the tangent of the circle, that is due to inertia of direction. The velocity at any point is along the tangent of the circle. So if the string breaks, the object will fly along the tangent only. So in this case, the object is not moving towards center, that is because of centrifugal reaction. But where is the centrifugal reaction experienced? Is our finger, my finger. When you are rotating the object, the finger, you will experience the force of the string on your finger, which is towards the object. But object is object is maintaining having the centripetal force that is appearing as a tension in the string. So when it is moving in a circular path, the tension is acting toward the center and the reaction force is acting away from your finger toward the object. Your finger will experience a force away from the finger, from center. The finger itself is the center of the circle. So that is a centrifugal reaction. Centrifugal reaction is experienced by the object which is at the center of a circle and providing the necessary centripetal force. So because from here this object, whatever is the center point of the circle, that experiences a centrifugal reaction acting away. For example, if you take the planets revolving around the sun, then compulsory centripetal force is required for the object to move in a circular path or any curved portions. Even if elliptical orbit also, at a given instant that part of the ellipse is taken as a curve having the circular motion, but otherwise we take the average radius as a circular motion comparison, but compulsory centripetal force is required. So centripetal force is provided how the gravitational force of attraction to the planet and sun provides the necessary centripetal force. Then who will experience the centripetal force and centrifugal reactions? Centripetal force is not experienced by these objects, it is only provided in between, that is the gravitational force. Gravitational force between these two is always action and reaction force. If the sun attracts the earth also attracts the sun with the equal forces. So sun attracting the earth towards the center of the circle, means towards the sun itself is a centripetal force. But earth attracting the sun towards the earth is a centrifugal reaction. Both are equal and opposite, though no one is moving towards each other. But both are experiencing a force. Equal and opposite, they are cancelled because they are acting along the same line of action. Action reaction force are cancelled, hence there is no resultant motion along this line. But it is due to inertia of direction, it continues to move in a circular path, the planets. So sun experiences centrifugal reaction, whereas earth experiences centripetal force. Centripetal force is required. This point is important. Is required for any object to move in a circular path. But if continuously circular path is maintained, means the centripetal force is balanced by centrifugal reaction. Force is equals to minus of centrifugal reaction. Both are equal and opposite directions. Centripetal force is balanced by centrifugal reaction. Hence, net force is 0. So, for this object, this is F action, that is centripetal force, this is going to be F reaction, opposite directions. Both are equal and opposite, and they cancel it. The resultant motion is not there along this line for this object. Then what is providing the centripetal force? For any object, compulsory centripetal force is required, means examples are required for this objects moving in a circular path where the centripetal force is provided. For planets revolving, for planets revolving around the sun, the gravitational force of attraction between the sun and planet provides the centripetal force. The gravitational force of attraction between sun and planet, means Earth or any planet you can take, provide necessary centripetal force, and electrons revolving around the nucleus in a circular path, or even an elliptical path also taken, or curved path we can say, but here generally we talk about the circular motion, circular path. Then electrostatic force of attraction, between electrons, that is negative charge, and nucleus. Nucleus has the protons and neutrons. Neutrons don't have a charge. We talk about protons. Electrons negative and nucleus positive. Electrostatic force of attraction between the electron and the nucleus provides centripetal force. If the centripetal force disappears, means gravitational force, for example, disappeared for these planets, for the planets or sun, etc., what happens is all the objects will fly away along a tangent to the path at that point. Even Earth also, if the sun stops attracting the Earth, at that instant where the Earth is there, it will fly in the same direction along a tangent. Next is, if a stone is tied to a string, is tied to the string and rotated in circular path, then tension in string provide centripetal force, necessary centripetal force. Tension in the string is nothing but centripetal force. If the string breaks, tension is not, that means string is not tight. Not tight means string will be broken. When broken, what happens to the object? Stone tied to the string, it will fly away along the tangent to the path. At that instant, where is the direction? The direction will fly away. So here, tension in the string. Generally, they ask the problems here. Tension in the string is nothing but equals to centripetal force, which is nothing but equal to mv square by r. R itself is the length of the string we have to take, that is radius of circle, it's equal to length of the string, is equals to m omega square r. Generally we need only these two formulas for the calculation. R itself is length of the string, radius of circle is or length of string take. Next example is, if a vehicle is taking a turn on level roads, then what provides the centripetal force is friction between the tires and ground, provide the necessary centripetal force. If it is unbanked road, if the banked road you have taken means component normal direction provide the centripetal force apart from the friction. For vehicle taking a turn on level roads, level curved roads, for vehicle taking a turn on level curved roads, the friction means friction itself is a force. The friction between tire and roads or ground we can take provides centripetal force. If the vehicle is taking a turn The centripetal force is compulsory required towards the center, that is provided by the frictional force, because it's trying to skid in this direction, it's trying to go along the tangent, but when it's trying to go in this direction skidding, this frictional force opposes the tires skidding, the frictional force is acting toward the center. If the friction is not there, if you put an oil there, and somewhere on the road, oil is there, or a slippery ground is there, soil, the wet soil is there, in such case when you're taking up to this here, road is good, here loose soil is there, then the vehicle cannot take a turn. Instead it skids along the tangent, because there is no friction, means there is no centripetal force. What happens if the centripetal force suddenly disappears? Means the object will fly away along the tangent. They may ask you things problem linked to gravitational topic actually. If the force of attraction suddenly disappears, or gravitational force suddenly disappears, there is no centripetal force, means all the planets fly away along the tangent to the circular path. Similarly, the stone tied to string also fly away along the tangent to the path at that instant. Next point is centrifugal force. Centrifugal. It is the pseudo force or imaginary force. P is silent here. Pseudo force experienced by the object in rotation. What is the force experienced? Is directed, the force is appearing to be directed away from the center of the circular portion. This force appears to be directed away from center of circle. It is not a real force, it is a pseudo force. Pseudo force also means fictitious force. Fiction means imaginary. Fictitious, pseudo, or imaginary force. Why this force actually appearing is? This force is experienced because of the inertia of direction. If the object is trying to move, or if you travel in a bus at the curved path, the bus is taking a turn. Then to the left side it is taking a turn. When it is taking the left turn, then you will feel a force acting towards the right side window. You will be feeling pushed toward the right side window. What is happening is every instant you are trying to go along the tangent. Bus is also trying to go along the tangent, but bus took a turn. Our body did not take the turn instantly. The result is that you are trying to go along the tangent to the path. Along the tangent at the instant, whatever the path is there, that will try to go in the direction. So if the bus is going straight, suddenly turn to the right side. It bus turned, but your face is this side, but your body is trying to go in the previous directions. The previous direction is towards the left side. The turn this side means it is towards left side. The centrifugal force, which is experienced here away from the center. This is like curve. If you imagine at that instant, this is going to be towards the center. If the force you are imagining is away from the center, that is because of inertia of direction. Inertia of three types. One is inertia of rest, inertia of motion, inertia of direction. These inertial forces, whatever are appearing, it is not real one, it is appearing, is called as a pseudo forces. In case if you take inside the bus is going straight, okay, it stopped. Sorry, initial velocity is 0. Suddenly started moving with some acceleration. Suddenly moved forward means if you are standing in the bus, then you will fall backwards. Your mass is m. The acceleration of the bus towards right side is a. Okay, then you will feel the force acting towards left. But what is actually happening is you are at rest, your feet is in ground, in contact with the bus. So your feet is moving along with the bus, your body is still at rest due to inertia of rest. So upper body, which is flexible, will fall backward directions. But we feel the force acting backward direction, that is nothing but equal to pseudo force. What is the pseudo force in this case? We have to imagine is F is equals to the mass of the person into acceleration of the vehicle, that is A, but it is directed away from the acceleration of the vehicle. This is nothing but equal to pseudo force. Next, if the bus is suddenly stopped, when the bus is suddenly stopped, what happens? You are applying the brakes, means retardation. Retardation is opposite to acceleration. That means you are stopping here in this direction. This retardation is acting towards left side, opposite to the acceleration. So the person now is already in motion previously with some velocity. Suddenly brakes are applied. So the feet may come to rest, but upper body still in motion. The same velocity of the bus will fall forward directions. Now vehicle is experiences deceleration opposite direction, retardation, but the person experiences force in the forward direction, falling forward direction. That is a pseudo force. Again, what is pseudo force formula is F equal to ma. A is the acceleration of the vehicle or deceleration of the vehicles. So this force, pseudo force, is not real force. It is a imaginary force, but what is actually happening is inertia of motion, inertia of direction, or inertia of rest is the case happening. Now in this centrifugal force we talk about inertia of direction. This is due to inertia of rest, from rest starting moving, he already moving, applied brake, suddenly stopping, it is inertia of motion. Now we are talking is inertia of direction. So definition, if there is pseudo force experienced by the object in rotation, this force appears to be directed away from the center of circle. It is imagined, it is actually produced because of inertia of direction. It is produced, not real one, please. But if we imagine it is there, then how it is imagined is because of it is produced due to inertia of direction. We are feeling it directed away from the center. So centripetal force acting towards left side, towards center of the circle if the object is moving in a circular path in anti-clockwise direction here. Then centrifugal force is imagined by the object, not real ones. Due to inertia of direction only, this is going to be centrifugal force. Careful with that, don't use the centrifugal reaction. Centrifugal reaction is between the objects only, center and object. Center, whatever the providing the necessary centripetal force, that is experiencing the centrifugal reaction. This is centripetal force, centrifugal reaction, and centrifugal force is imaginary force experienced only by the object in rotatory motion. You will daily life we experience pseudo forces, not real forces. Real forces only when you get the pain you will feel maybe, but what you are experiencing or you are pushing the object, there you will notice. But inertia of whenever the daily life, in the bus if you are moving, or if you go to the amusement spots that chairs rotating, in that case also you will experience force acting away from the center. That is the centrifugal force. Why when we have to consider this force as a real forces, or we need to consider the equations. And what is the value of the centrifugal force? The centrifugal force is not real force, but is numerically equal to centripetal force only we take. What is the centrifugal force is nothing but, and you will not be asked this part. Centrifugal force daily applications only required for you. Problems will not be asked, but we need to know it. What is the formula you have to take for centrifugal force? Sorry. Force is equals to mass into centripetal, same formula as the centripetal force, that is mv square by r, which is equals to m omega square r, or mv omega we can take, and relation v equal to omega r. This has more applications. Centrifugal force has many applications even in biology to separate the PPT in the liquids, your urine test cases, or even in the case of the blood sample, separation of the denser particles. We take the centrifuge instrument that contains the test tube, liquid and sediments, heavier particles and light particles. If you rotate with some angular velocity around this axis, generally to balance, the two tubes are taken, rotated with the high speed. When they rotate at the high speed, what is constant for all rotating points objects is all objects have the same omega. Here omega is constant. We discussed this point already before. If the fan is rotating, every point of the object will have the same omega, but they do not have same velocity. V is different, omega is constant, so V is proportional to R, more V, more centripetal force, or even if you take in this way, so more radius, omega is constant here. When omega is constant, more mass, more centrifugal force, more radius, more centrifugal force is experienced by the particles. So more mass, heavy particles are pushed away from the center. The result is that high dense particles are pushed here, light particles are collected here, near to the axis of rotation, light particles. Or we will take here M1 particles, this is M2. M2 is greater than M1. More radius, if omega M constant, if you have taken more radius, particle far away from the axis of rotation, this is the distance from the axis of rotation is taken as a radius. More radius, more will be the centripetal force. And if the girl is rotating, the hair will rise up. Why? Because of centrifugal force, which is not real force, but imaginary force also makes the hair to rise horizontally. They try to go far away maximum distance from the axis of rotation. The result maximum is nothing but equal to circular motion they will take. The maximum distance from the axis of rotation means maximum radius. And with the help of the centrifuge, high ultra centrifuge has a more than 20,000 revolutions per minute. They are used to separate gene materials. That means RNA, DNA separation, even microbe separation from the objects is possible with the help of ultra centrifuge. And to separate honey from the bee wax. And in the case of the washing machines, cloth dryers, and in the case of washing machines, the drum will be there. The drum contains the holes, and the cloth with wet cloth you are putting inside, and drum is rotating with some angular velocity. And due to centrifugal force, all the particles are trying to go away from the center. The result is more omega, more centrifugal force. Due to centrifugal force acting away from the center, particles try to go in the direction, but it's actually along the direction of axis of rotation. Along the tangent to the circular path. So these particles are able to pass through. This means water molecules are thrown away from these holes. The result is without water, all the thrown away, the cloth becomes dry. And honey is separated from the bee wax in the same principle. That is also put in the drum with the holes, and drum is rotated. The honey will flow out of these holes, thrown out and collected in a container, and wax will remain inside. Similarly, from the milk, cream is separated from the milk by the same principles. Churner, it is called as in the villages also they separate this cream. Buttermilk, from the butter is separated from the buttermilk by these rotating veins called as the churners, and heavy particles are thrown away, which are butter particles, whereas milk particles are thrown away, butter is collected at the center, which is the lighter ones. These are all the applications of centrifugal force. When we consider the equations of centrifugal force, where we actually required is to apply the Newton's laws for the rotating objects. Or in the case of the non-inertial frames, we have the two kinds of frame of reference. One is called as the inertial frames, another is called non-inertial frames. Inertial frames. Inertial frames of reference. Acceleration equal to 0, velocity equal to constant. Newton's laws are applicable directly. That means you can write directly F equal to ma. And that non-accelerating reference frames is called as acceleration is 0. It's called as a non-accelerating frames. That means bus is moving with uniform velocity. Velocity is constant. Then acceleration is 0. We are not talking about the acceleration to gravity here. G will be acting perpendicular directions all the time, same directions. That is not affecting here. We are talking about the change in velocity terms. So acceleration is 0. Then that is called non-accelerating frames. In that case, directly we can apply Newton's laws for the object. If the velocity is constant, if you are playing the carom board inside the bus moving with a constant velocity, in the aeroplane traveling with uniform velocity, or even the bullet train traveling with a very high speed, but velocity is constant, in all cases it is the effect is same as the vehicle at rest. At rest or moving with constant velocity, if you are playing the carom boards, then whatever they are playing in the room at rest will be show the same result as the non-accelerating frames. Next type of frames is non-inertial frames. This is the inertial frames. Next is non-inertial frames of reference. In this case, acceleration is not equal to 0. Velocity is not equal to constant. These are called as a accelerating frames of reference. Accelerating frames of reference means bus is suddenly accelerating forwards. So if you are playing the carom board, before you are hitting only the coins will slide backward direction, sir, because of pseudo force. And if already you are playing in the caroms, constant velocity, the bus is moving, you are playing the carom, suddenly brakes are applied, then all coins will go forward directions as if the pseudo force is acting on them. That means the acceleration is felt, the vehicle by vehicle is accelerating, then that is called as a non-inertial frames. But in the non-inertial frames, if you want to apply the Newton's laws, that means you are also applying the force, vehicle also accelerating. In that cases, there are two forces you need to consider. One is your force, another one is the pseudo force. Then we have to consider the pseudo force into consideration, and one of the pseudo force we are going to apply here is circular motion. So in the case of circular motion, that is a centrifugal force. We need to consider it as a pseudo force. Circular motion is related to non-inertial frames. To non-inertial frame of reference. Why? Because non-inertial frames means what acceleration is required for non-inertial frames. What is acceleration? Centripetal force. Centripetal acceleration due to centripetal acceleration. Every rotating object compulsory will have the centripetal acceleration. Then what you have to apply to apply the Newton's laws for the rotating frame of reference, we have to consider the pseudo force, that is a centrifugal force. To apply Newton's laws. To apply Newton's laws to rotating frames. The pseudo force, that is centrifugal force, is considered. That means centripetal force is towards center is actually real force. Centripetal force, centrifugal reaction are real forces. Centrifugal force is not real force, it is that centrifugal force is not real force, but we need to consider as a real force only when we are taking that. If you want to apply the Newton's laws, if you don't want to apply Newton's laws, it is not required to consider only. So centrifugal force considered as a real force along with the other centripetal forces when you are taking it as, when you want to apply Newton's laws.